Assalamualaikum and good day everyone. We are from group 3 and today we are going to present our practical work for the course DE 20143 Semiconductor Device. Our topic is BJT characteristic in common emitter configurations. Before we start, let us briefly explain the background of this experiment. A bipolar junction translator or BJT is one of the most important semiconductor devices. It can be used as the switch or amplifiers. In this practical, we can focusing on the common emitter configuration, which is the most widely used because it provides good current gain and voltage gain. The main objectives of this practical work are: number one, to demonstrate step-by-step procedure for measuring voltage and current using a multimeter. 2. To calculate the translator parameter with a beta DC, saturation current, and cut-off voltage. Now, let's move on the first part which is the measurement procedure.
In this part, I will explain the step-by-step procedure for measuring voltage and current in the circuit. First, we prepare the circuit using a transistor in common emitter configuration. The base terminal is connected with a resistor and variable input. The collector is connected through a load resistor to supply voltage and the emitter is connected to ground. Next, we set the multimeter to voltmeter mode to measure the voltage between collector and emitter. Then, we set the multimeter to emitter mode to measure the collector current. To do this, the multimeter must be connected in series with the collector. We vary the base current by adjusting the input, and for each value, we record the corresponding collector current and collector emitter voltage. These measurements are repeated several times until we have enough data to plot the BJT characteristic curves, which are the input characteristic and output characteristic. By carefully following these steps, we are able to obtain accurate measurements of the transistor behavior.
Once we have collected the major data, we can move on the calculation. 1. Beta DC. The current gain of the transistor is calculated using the formula beta DC equal frac IC IB. 2. Saturation current. This is the maximum collector current when the transistor is in saturation mode. At this point, increasing the base current further does not increase the collector current significantly. It means the transistor is full turned on and collector emitter voltage is very small. 3. Cut-off voltage. This is the point where the transistor is in cut-off mode. In this condition, the base current is almost zero and therefore the collector current is also very small or almost zero. By analyzing the recorded data and the plotted graph, we can identify the value for beta DC, and these parameters are very important in designing circuit because they tell us how the transistor behave in different operating region.
From the experiment, we can discuss that BJT in common emitter configuration has the important region. The cutoff region where the transistor is off and no current flow. The region where the transistor works as an amplifier and collector current is proportional to base current. The saturation region where the transistor acts as a switch and fully turn on. We also learn how to properly use a multimeter to measure voltage and current in transistor circuit. By doing so, we were able to calculate BDC, identify the saturation current, and determine the cutoff voltage. In conclusion, the practical work has helped us to better understanding the characteristic of BJT in common emitter configuration. The knowledge of transistor parameter is essential electronic because BJT are commonly used in amplifier, oscillator and switching circuit. That brings us to end our presentation. We would like to thank you to our lecturer and teammate for their cooperation, and thank you to everyone for listening.